Hi guys, I'm Dr. Stevens. Today I'll be demonstrating recrystallization. We'll be recrystallizing benzoic acid, and for the purpose of this demonstration I'm going to use water since it's not flammable or toxic and I'm not inside a hood enclosure. Benzoic acid does recrystallize nicely from water. First thing we need to do is decide which type of glassware we're going to use. We could either use an E-flask or a beaker for recrystallizing at the beginning. We do need to choose the appropriate size though. Got about 1 gram of compound. I already know some solubility of this compound. I know it's going to take probably 50 to 100 milliliters or maybe more. So I want to make sure I choose a pretty large flask as opposed to a small one. If we choose a small one, we might run out of room. At this point, it really doesn't matter. I'm going to go with a larger flask. I'm going to go with a E-flask. The compound will be put into the E-flask. For the purpose of this demonstration, I'm going to include 2 impurities. 2 common impurities you encounter. One will be insoluble impurities, and for that I'm going to use a little sand. The other type of impurity you will commonly encounter is a soluble impurity. For that, I'm going to use a little sugar. Now, of course, for this demo, I'm adding these sort of fake impurities. If you're in the lab, you may have genuine impurities, and that's the purpose of recrystallizing. Okay, we've got our compound in our E-flask. There's a variety of solvents we can use to recrystallize. As I mentioned, we're going to use water. In lab, typically you'll use maybe an alcohol, such as methanol or isopropanol, or maybe something like nonpolar hexane, cyclohexane. There are a variety of solvents. First question is how much solvent. By the way, we always want to use a stir bar. We're going to be heating, we want to use a stir bar. Stir bar added. Got water here. How much water do we add? We add enough water just to get it stirring. And so, what if I add that much? Well, as you can see, it's really just soaked it up and I can't stir that. That is not enough. We need to add enough solvent to get your solid so it will stir, not stick to your glassware. If it sticks to the glassware, it's prone to scorching. That is enough solvent to start with. So at this point, we want to start heating on our hot plate. So I've got the heat on, and I'm going to give it some stirring. So at this point, the idea is to dissolve the compound in the smallest amount of hot solvent. Again, you always want to stir, especially when you're heating with an organic solvent. If not, the solvent will have a tendency to get hot and just start spattering. So when we bring this up to heating, either the compound will dissolve, meaning we have enough water there to do what we want to do, or the compound will not dissolve. If the compound does not dissolve, then we need more water. While heating, a good little trick is to cover your flask or beaker with a watch glass. As vapors come up, they can hit the watch glass and they can then condense and then fall back down. And so you won't lose your solvent that way by evaporation. Also, once the solvent starts dripping from your watch glass, that tells you that it's indeed boiling. Now, while this is heating up, let me say, benzoic acid I know does recrystallize nicely from water. With the benzoic group, it's just polar enough to dissolve in hot water, but it will crystallize upon cooling. Majority of the compounds that you deal with in lab will typically require an organic solvent. So, Again, while this is heating up, let me move to our next steps that we'll be doing. Once this dissolves, the next step in the procedure is to do a hot filtration. We're going to filter this while hot. This is going to be done by gravity. Anytime you're filtering hot, you want to do it by gravity. This is going to be used using a fluted filter paper. These are actually pre-fluted. In lab, you'll actually be using a flat circle, something like this, which you'll have to fold and flute yourself according to the instructions in your lab techniques book. I'll let you read about that. You can buy pre-fluted filter paper, but it will cost you about 10 times as much. We're going to filter this. What's the purpose of filtering? What will we remove when filtering? That is when the insoluble impurity will be removed, which in this demo is our sand. The sand will never dissolve in the solvent. So this is getting pretty hot. You can look at this. Looks like about half of my compound is dissolved. It's pretty hot there. I got vapor condensing on my watch glass. It's pretty much boiling down there. Benzoic acid is not completely dissolved. So at this point, I'm going to add more solvent. How much more solvent to add? Well, it looked to me like half of the compound had dissolved. I started with about 20-25 milliliters. So to get the other half dissolved, I added another 20 to 25. That did cool it off a little bit. It's going to take some time to get back to boiling. By the way, this is your plastic gravity funnel. It's supported in your hood by what's called a ring stand there. And then of course we're going to filter this into something. Now what size do we filter into? Do we want to use a large? Well, at this point we want to determine how much solvent we used. And this is coming along nicely. It looks like it's pretty much dissolved. A little bit floating on top. And we got about 60 to 70 milliliters in there. Because of that, I'm going to use a flask that sort of suits that volume, and I'm going to go with, I'll use a beaker on this end. We could use either way. I'm going to use a 150 beaker. Now there's 100. Certainly I don't want to use a 600. If you put 150 milliliters in this beaker, it's just going to be on the very bottom, and it's going to risk evaporation, and it's going to be very difficult to get your end product out of such a big beaker. So I'm going to go here. I'll lower this down, so when I hot filter, I'll go into this here. This is nice and hot. How hot is it? Well, water boils at 100 degrees. If this was methanol, this would be about 65 degrees. You need to know the boiling point of the solvent you're working with. At this point, it looks like all of our compound is dissolved, but on the bottom I see something that's not dissolved, and that is, of course, our sand. What about the sugar at this point? Is the sugar dissolved? Well, if you know anything about sugar, you would say yes. It is dissolved in the hot water. The sand is our insoluble impurity. It never dissolves. The sugar is going to be a soluble impurity. So at this point, I'm going to do a hot filtration. Now, before you do your hot filtration, sometimes you run a little solvent through your filter paper. Now, you want to be careful about wasting solvent. If you run water or your solvent through your filter paper, it will sort of loosen up the pores and make it filter a little bit faster. Sometimes you can even pour hot solvent through. Once it goes through, since this is water, I'm going to pour it back in just here. If it was solvent, you wouldn't want to pour it back into an original container in lab. So now we're ready to hot filter. We can take this off. It's a little hot because it's 100 degrees. I'm going to turn my hot plate off. I'm going to pour this through. Just going to pour, keep on pouring. Pretty hot here. I'm going to set it down kind of hot. Keep it covered. Going through. Depending on how long you have to sit, you may let it keep warming. You don't want your compound to crystallize. So that went through pretty well. A little bit of product up here. We can chase that through. Stir bar went in there. A little bit of compound in here. I can take a little bit of my solvent. Get this hot again. Now my stir bar is not in there, so I want to be careful. I don't want this to start spattering. I can kind of swirl it by hand. Any residual compound can be dissolved. And I can use this as a little rinse to sort of rinse down my filter paper and chase everything through. And so that's our hot filtration. The purpose of the hot filtration is to remove insoluble impurities. In this demo, that would be the sand. Where's the sand? There's some in my filter paper. Because it's heavy, there's some remaining in the flask. It didn't even come out. But I rinsed with hot water. All the benzoic acid should have been chased out through the filter paper and down here. So now we have removed the insoluble impurity by hot filtration. During your lab work, you may not have insoluble impurities, or at least you may not think you do. It's always good practice to do a hot filtration. Always do this. If you hot filter, there's certainly no insoluble impurities now in your recrystallized fraction. So now I can set this aside. That's been rinsed out. Now we have this here. It's actually already starting to crystallize. There's certainly no sand here. It's still a little warm. I'm going to also cover this with a watch glass to cut down on evaporation. And the idea now is to let this cool and hopefully deposit crystals or repurified solid. Now once this cools a little bit, we're going to put this into an ice bath. An ice bath here. Bath is important. This is both ice and water. Just ice is not going to be as cold as ice and water. Stick your finger in it. What you can actually do is get this sort of thick. Kind of thick, so when we put our beaker in, it won't have a tendency to turn over. There's already solid recrystallizing on the bottom. It's still a little hot. At this point, we can ask, where is our sugar? The sugar should have been dissolved. It should be dissolved in the water. It is a soluble impurity. Your soluble impurities are a little bit more difficult to remove. It's based on them staying dissolved, but your compound of interest crystallizing out selectively. Sometimes that happens readily. Sometimes your insoluble impurity also crystallizes out. But in the ideal case, the insoluble impurity will never crystallize out. So this is cool enough to ease into our ice water bath. Sort of kind of ease it in. It's still a little warm. I think that's sufficient. We can get it down in there. Looks like it's sitting nicely. You certainly don't want this to turn over in your ice bath. You'll be fishing for crystals. There, got to keep an eye on that. I've seen students sometimes use your test tube holder and sometimes clamp it like this. I've never done that myself, but a lot of students do that. Take a look at it. You can see we're getting a good amount of crystals forming now out of the water. It's still actually a touch warm. It's cold on the bottom, room temperature sort of on the sides. Certainly it can chill a good bit longer. At this point, we let it chill sufficiently. How long do we let it chill? Well, how much product do you expect? I started with about 1 gram of benzoic acid. Recrystallization, I hopefully will get maybe 80% recovery. That'd be great. So does that look like about 0.8 grams? Well, it's a significant amount. If there wasn't much there, then I'd need a lot more chilling. This is coming out nicely. At this point, we may let it sit here, give it another 5 minutes or so. We can clean up some of our glassware. Just make sure it doesn't turn over. While it's chilling, we can prepare for our next step. That's going to be collecting our crystals. That's going to be another filtration, but that's going to be a suction filtration. There's a clamp in your hood. To do a suction filtration, we need a Buchner funnel. Buchner funnel, we use the circles. The circle should fit. Please make sure your circle fits. There's different size funnels, there's different size paper. This is going to go in a filter flask or with a sidearm here, and a neoprene adapter, which allows you to have a good fit of your Buchner funnel. This is going to be clamped. I see a lot of students who do not clamp this. I'm not sure why. That's poor practice. There's clamps in the hood, and they're meant to clamp your flask here. And then on the end here, we're going to apply our suction hose, which is in your hood. Okay, at this point, our recrystallization has been in the ice bath for about 5 to 10 minutes. Good amount of solid here. At this point, we're going to suction filter it. Good to have a little spatula here. Some of my solid is sort of adhered to the glass. I'm going to sort of scrape it loose. I've got my suction already turned on. Neoprene adapter, good suction here. I can feel it with my hand. Sometimes you can pre-wet your filter paper. If you got good suction, it's not needed. If your suction is weak, what can happen is your filter paper can float on your liquid. That's one reason to sort of pre-wet it to keep that from happening. Got pretty good suction here. So at this point, I'm going to pour it through. Keep pouring. Came out pretty nicely. A little bit of crystals left in my beaker. I can use a little bit of solvent to rinse that out, but I want to use either room temperature solvent or even cold solvent. Certainly we don't want to use hot at this point. Hot solvent will dissolve our compound. I know this compound won't dissolve much at room temperature solvent. A little bit of rinse that out. Now I can let this sort of dry under suction. So, at this point, where's our sugar? Our soluble impurity. Hopefully the sugar is in our filtrate and it will never precipitate out, in the ideal case. At this point, your filtrate eventually going to be discarded into the appropriate waste container, but you do have to be careful. Never discard a filtrate until you're sure you've got what you want here, suitable amount. Sometimes this can be rechilled and give what's called a second fraction or a second crop of crystals. If you weigh this and you've got 80 to 90% recovery, you're probably not going to look to have anything here. But if this is only about 10 or 20%, then maybe your other portion is in here and you don't want to be so quick to pour this out. So that's the demo of a recrystallization procedure, recrystallizing benzoic acid from water.